Hey guys, this is the video for 5.2. Okay, and I taught this lesson over 2 days, but for the video, I'm going to put it in one video. Okay, so we're getting into exponential functions. So I want to, in the beginning of this video, I'm going to use this blank space in your textbook to just kind of go over some general stuff about exponential functions. Okay, the generic form of an exponential function is f of x equals a number times another number. Well, I gotta clear this out. So a number times another number to the exponent of x. Okay, and the a is a number that represents your starting amount, also known as your y-intercept. Your b is your growth or decay factor. Okay, growth. We say growth when we have a function that is increasing. We say decay when the function is decreasing. Okay. What we did in 5.1 was compound interest, and that's a very specific application of exponential functions, but I'm going to use it to point out the similarities here. So we did, your principal according to time would be your initial investment, your principal, times parenthesis 1 plus the rate, that's your percent that you converted to a decimal, to the t power. So here's what I want to point out that's the same. Okay, your initial investment would be your starting value. That's the same. If I add together 1 plus r, we did that in class for 5.1, that equaled a single number like 1.07. That's your b. And then your exponent. It's very specific. It's t for time in this specific situation of compound interest, because interest grows over time. And the generic is x is always time. So it's the same elements that you're using. Okay? So I wanted to point out those things before we got into 5.2, because you should really know what the basic structure of a exponential function is. Okay, in the book we're going to practice writing and using some exponential functions. The population of downtown is 20,000. The population of uptown is 6,000. But over many years, people have been moving away from downtown at a rate of 1.5% every year. At the same time, uptown's population has been growing at a rate of 1.8% per year. So let's pull some things out. Okay, first of all, 20,000, that is my starting amount. That's my A. Okay, for downtown. My starting amount for uptown is 6,000. We're going to be writing two different functions. Downtown has a rate, my R, of 1.5%, but I've got to move the decimal over. 0.015 is my R. Also, if people are moving away from downtown, that would make it negative. Uptown's population is growing, and that again is an R value, not R value like correlation coefficient, but R for rate of 0.018. And it's positive because we're talking about growing. Okay? Independent and dependent, we talked about that in class. I'm not going to put it in the video though. I mean, independent's always time, dependent is your population. Okay? Uptown's population is increasing because it's going up. Downtown, people are moving away. It's a decreasing function. Okay? Let's get right into using these values to write the function. Okay, 5A. For Uptown, they started out with 6,000. And we're going to use the compound interest formula. We're just not using it for interest this time. We're using it for population. Times, parenthesis 1, it's growth, so plus, and Uptown's population growth rate was, I got to go back and look at it, 0.018. 0.018 to the t power. Then we'll simplify that. 6,000 times 1.018 to the t power. Okay? Now let's go back and use that equation to find out the population in 2 years or 3 years. So going up, okay, in 2 years from now, $6,000 times 1.01, is it 8 or 5? I've done this so many times and I still mess them up. 8 to the second power. Okay, and we'll come back to that in a minute. U of t for 3 years is 6,000 times 1.018 to the third power. Now, for these problems, to get answers, we can type them into the calculator as you see them. But I'm going to give you a little tip. On your homework for this assignment, 5.2, you're going to be using the same equation over and over and over again to answer different values, different numbers of years. So one thing that, you have to write down the substitution. You have to write the equation with 2 subbed in. You have to write the equation with 3 subbed in. As a matter of fact, this should be a 2, this should be a 3. Okay? So instead of typing that in over and over again, you can use the table feature on your calculator. Times 1.018 caret x. Remember to put an x in because we're going to use a table. And at first we're looking for 2 years. Now, remember that the column shows you the rounded version of the number, and then down here at the bottom it shows you the entire decimal. But since this is population of people, we don't want a decimal at all. We want 6,218. 9 tells that to go up. 6,218 people. And then if we look at it for level 3, 6,330 people. Mrs. Andrews, if all I'm going to do is type it in the calculator and look at the table, do I actually have to write down this step? And the answer is yes. You have to show the graders of your regents or your homework papers or your test papers or whatever that you understood what the value of 3 was supposed to be doing, that it subs in for t. Okay, so yes, you have to show subbing in. Okay. Now we're going to write and simplify an expression that represents the population of downtown. But let's go down further. 8. That's where we actually write the function. Okay, downtown, leave yourself room to write 2 lines of work. Downtown started out with 20,000 people times 1. Now, we've been doing plus signs right along because we're always talking about something that was increasing. But for the first time, we're going to talk about something decreasing. So remember how we said r was negative? It was going down. So we're going to put minus 0.015 to the t power. So d of t equals 20,000 times 0.985 to the t power. Okay, we just subtract it. So then we can scroll back up and talk about population 2 years from now. Okay, so d of 2 equals 20,000 times 0.985 to the 2 power, or d of 3, 20,000 times 0.985 to the 3rd power. So we have to write down what we did. Guys, if for some reason you made a typo in your calculator, you'll get the wrong answer. But at least if you write down what you're doing, right, that you understand that you're subbing in 2 for x, or 2 for t, or 3 for t, whatever, then we at least know, okay, you know what you're doing. Maybe you just made a typo in your calculator, and you don't lose full credit. If you don't write this step and you have a typo in your calculator, that's it. No credit, because we can't tell what you did wrong. So go to your y equals again. 20,000 times 0.985 caret x. And we're specifically looking for the value at 2 years, 19,000. Now it says 19,404.5 at the bottom, but the d of 2, yep. 19,405, but remember that's a rounded value. And d of 3 is 19,113, but again, if you look at the bottom here, you can see that's a rounded value. And that's okay this time, because we're talking about people, and we can't have partial people. But if we were talking about a problem about money increasing or decreasing exponentially, and you just go by the number that's in the column, then you're going to miss round, because it's going to have decimals that you don't see. Okay? Okay. So 5-2. The first section of your homework is just having you write and then simplify some functions. Okay, Youngstown has a population of 12,000. Its population is increasing at a rate of 1.2%. So that means my R equals 0.012. And that's my starting value. So Youngstown, in terms of time, starts off with 12,000 people, and it's 1 plus 0.012 to the t power. Now, why is there a 1 here? The 1 is so that when you distribute, you don't distribute. But if you were to distribute, it's counting the 12,000 you started with and adds on the 12,000 that you're multiplying by the increasing rate. Okay? If you don't understand why there's a 1 there, that's fine. Just don't forget that it's there. So 1 plus that, 0.012 would be 1.012 to the t power. So we just added those together and simplified. Greenville has a population of 8,000. That's my A. Its population is decreasing. So that's going to be a minus 0.0175. Yep, it's kind of a long decimal, but you know what? In real life, it's not nice, pretty numbers. It's often decimals. If you go to a bank and look up their interest rates, they're not usually whole numbers. They're usually like 3.5% or 4.25% or something like that. Okay, Greenville, in terms of time, has a population that started out at 8,000, but now it's 1 minus 0.0175 to the t power. Guys, a lot of people leave off to the t power because it's just something you have to remember to put there. You don't have to figure it out. Don't forget to put it in there. Without that exponent, it's not an equation. Times 0.9825 to the t power. So I want to point out, guys, that this was a population that's increasing and it was 1 plus. This was a population decreasing and it's 1 minus. So what I want you to understand is when you're multiplying by, this is our b value, these are b values. The b value, remember, is your growth or decay factor. When you're taking 1 and adding something to it, anything greater than 1 would be a growth factor, and anything less than 1 would be a decay factor. So if I see an equation and I look at the b, I can tell immediately whether it is a growth or decay function by looking at the b value. Moving on to the next section, they're giving you an equation and all you have to do is sub in. So, you know what I would honestly do for each of these is write P of 3, here's the equation, equals 16,000 times 1. I left the mouse on there and it bumps it and $16,000 times 1.015 to the third power. P of 10 equals 16,000 times 1.015 to the 10th power. I do that for each one of these. Okay, then I'd get out your calculator, type in the function. $16,000, too many zeros, times 1.015 caret x, and look at your table and look for all the values that it wants. So that wants 3. Okay, again, be careful. In this case, we want the nearest whole number anyway, but remember there's decimals, 16,371. And then I would just look for the 10 and the, all these other numbers that it wants, and just fill in the answers from there. Okay. Okay, the next part of your homework is not asking for you to sub in a t, it's asking you to sub in a p of t. So my equation is right here, and I'm saying 15,000 equals 18,000 times 0.988 to the t power. And it wants to know what value of t. How long would that take? So we're going to use the calculator for this. There's really no other way to do it until you take Algebra 2 trig and learn how to do logarithms, which we're not doing. So we're going to put in the equation 18,000 times too many zeros. 988. This software is making me crazy. To the x power. 18,000 times 0.988 to the t power. Okay. Table. Alright. Kind of annoying, but this is what you got to do. I'm going to go to the y column, and I'm going to scroll. And I want to find out, when is it 15,000? Well, somewhere between 15 and 16 years is when it crosses the $15,000 or 15,000 people mark. So that's really, the homework shows a decimal answer for that. And without logarithms, I don't really know how they got it. And the book itself doesn't show how they got it either. So, without logarithms. So between 15 and 16 years. Okay? Problem like 16 is kind of confusing because it says 1/3. 1/3 means 1/3 of what you started with. So if you started with 18,000 people, 1/3 of that is going to be 6,000. And again, you got to scroll. But I'm going to warn you, you're going to scroll for a while and you're going to get tired of it. One thing you can do is go to your table set and say, you know what, let's jump to another number like 30 and see where that takes us. Okay, we're still not at 6,000. In fact, from 30 to 40, we only get down to 11,000. So let's go to table set again and let's try 50. Okay, so we're getting warmer. Okay, at 60, we're at 88,000. So let's start table set and let's start at 70. Whoops, didn't click the 7. Oh my goodness, now we're finally getting there. Now I'm going to scroll because it's going to be soon. Oh, there it is. And it looks like it hits 6,000 on the dot. But it doesn't. It just rounded to 6,000. Okay? But you know what? To be honest, it's so close. You'd round it anyway. So it would take 91 years. I will say that 70 is a trick question. Okay, mathematically, it's never going to be 0. Eventually, it would round to 0. Okay, we're talking about people, so you would have to round to 0, but it's never actually going to be 0. Okay. Next, this is where I cut off on day 1 of teaching this lesson, and so from this point forward is where I started talking about day 2, where I started talking about these graphs and some elements of the graph. So this is back to your textbook again, and we've got an exponential function here. And we're used to seeing f of x, or I'm starting to try to get you used to seeing a times b to the x power. Well, Mrs. Andrews, I only see one number, and it's the one with the exponent. So the b here is the 3. When you don't see an a, it's an invisible one, because if I multiply 1 times 3 to the x power, doesn't really change anything. Okay? So that's why what I want you to recognize is that this is my A. It's what's going to be across from 0. It's my y-intercept. Okay? So starting to just emphasize the parts of the problem. Okay? Now I'm going to go to my calculator and I'm going to do the table part first. So y equals 3 caret x. Now, table set. The last problem we just did from the homework, we were in the 80s. I don't want to scroll all the way back down. So remember, you can table start, and since this table starts at -2, I'm going to type in -2 for my table start. Go to my table and fill in the values. 0.1 repeating. 0.3 repeating, we already knew 1 from being the y-intercept. 3, 9, 27. Then, the rectangle next to this in your book wants you to graph it. I think it's unfortunate they just give you a blank rectangle. They don't even give you a grid. Okay, but this will be a good opportunity to talk about setting the window. So, we want to make a graph that's going to fit. The default isn't going to work for us very well, because as you can see in this chart, we go up to 27. So we also have no negative values, okay? If you scroll through this chart, there's never going to be any negative values, and we'll talk about that in just a minute. So my rule of thumb is I know these numbers are going to get smaller and smaller and smaller, okay? And I'm just going to set my x minimum as, well, let's go back to the x-axis. I always set my x minimum and x maximum to be 1 more than what it is in the chart. So if my lowest x value in the chart is -2, I'll set it to -3. My x max I'm going to put as 4, count by ones. Okay. Y minimum I'm going to set as -1 so that I can see the x-axis. It's not resting on the bottom of the screen. But I'm going to put my maximum as 30 because I need to go, you know, my highest value is 27, but I'm going to set it at 30 because now I'm going to count by 5s. Why am I going to count by 5s? Because if I don't set it to count by something other than 1, it's going to make 31 hash marks on that tiny screen for the y-axis, and that's annoying. So we want to make sure that we still have something visually that we can kind of read. Okay, and then we'll hit graph. Now if you're at home and your graph doesn't look like this, I would rewind and then pause it on each screen of the calculator. Okay, your table set, your window, everything like that, so that you can see what it is that I made different. Alright, and then technically your book wants you to sketch this graph in right here, and I have magical powers on my board and can just put that on there, and in class I made you draw them, you know, sketching them. Okay? Alright, and then we've got some vocabulary here that we have to work with. Okay, first, x-intercept. X-intercept is where is this blue line going to cross the x-axis? And that's a trick question. It is never going to cross the x-axis because these values are, if we're going down the chart, we're always multiplying by 3. But if we work backwards, okay, like we're following the graph backwards, these values are getting smaller and smaller and smaller. But dividing something by 3, a positive number, dividing it by another positive 3, you can't ever get a negative that way. In fact, division by a number doesn't ever give 0 either. So if you can't get 0 and you can't get negative, then you can't cross the x-axis. So there's no x-intercept for this graph. There is a y-intercept, and it's at 0, 1. Okay? Very fun word to say. And parents, if you're listening, your child is not swearing, I promise. Okay? An asymptote is an invisible line that your graph seems to approach but does not cross. Okay? Seems to approach but does not cross. So in this graph, the x-axis is what my graph is coming down. It's getting closer and closer to the x-axis. It's getting closer and closer to 0, but it's not happening. So the asymptote is at the x-axis, but that's also known as the line y equals 0. Okay? Domain. If you forgot from chapter 1 what domain means, domain means your x values. What is x allowed to be? In an exponential function, your domain is all real x. And we say the word real because x can be whole numbers, can be positive, can be negative, can be fractions, can be decimals. There's no limitation on what type of number x can be. Okay? Just has to be a real number. Range is your y values. But in this graph, my y values are never going to be negative. If I look at this column here, I'm never going to have negative numbers and I'm never going to have 0. So my range is all real y greater than 0. And that connects back to your asymptote. The asymptote represents that invisible line where the graph does not cross, and so that is related to what your y values are going to be. Okay, the only values I'm going to have in my y value column, my f of x column, are positive numbers. Could be decimals, could be fractions, but it can't be negative, and it can go up to infinity. All right. Interval of increase or decrease. Well, exponential functions are always either increasing, as this one is doing, or decreasing. So if it's an interval, if it's always increasing, then we say the interval is increasing over the entire domain. Guys, that's a fancy way of saying that the graph is always increasing for every value of x. As x increases, the domain increases, the graph is increasing. Okay, so it's a wording that you're just going to have to memorize. It's increasing over the entire domain. Okay, for the sake of time, I'm not going to do all 4 book examples. I'm going to pick one more to do. Otherwise, this video is going to be so long. And if you're still awake and still with me, hi, thank you. One more, okay? I want to contrast this with D. All right, in D. D is tricky because there's a negative sign in front of the 4 to the x. So when we're talking a times b to the x, okay, the 4 is the b. The a is the -1. Whoa, Mrs. Andrews. Shouldn't the b be -4? The answer is no. Okay, this is really important, guys. Listen. An exponent only raises a base to the exponent. It does not raise a sign to the exponent. The only way b could be -4 is if the negative was in parentheses instead. And that would be a whole different ballgame. Negatives have to be in parentheses in order for that to happen. Okay? So that's a critical thing for you to know. So that means my y-intercept is -1. And I can do that without a graph and without a calculator. Okay? Y-intercept is -1. So then I'm going to go to my calculator. Go to my y equals, okay, -4 caret x. Go to my table. Okay, don't forget, this value, the first value I have highlighted right now, is actually rounded. It's actually -0.0625. Then -0.25, -1, -4, -16, -64. Setting up our window. I'm going to keep my same x minimum and x maximum because the x column didn't change from the other problem. But this time, I have all negative numbers. So I have to rethink through what my minimum and maximum would be. My minimum, okay, my lowest value is -64. So I probably want a minimum of -70. My maximum, I'm probably going to want to be 1, +1. I know this is going to go to 0 only, but if I go one number above that, it just makes it so that I can see the x-axis. And then y scale, let's count by tens this time. Okay, x-intercept, trick question, none. Exponentials don't cross the x. Pure exponentials that are not added or subtracted with anything, pure exponentials do not cross the x-axis. There's no x-intercept. The asymptote, again, is the x-axis, but I also want you to write y equals 0 because that's the name of the line for x-axis. Domain, it's still all real x. It is all real x for every problem in exponentials. There's no limitations on exponentials for your x values. However, your range these are all negative numbers. So my range is all real y less than 0. Less than 0. All negative numbers. Interval of increase or decrease. Well, this function is decreasing. So we say decreasing over the entire domain. And your homework problems are set up the exact same way as this. And you're just going to follow the example problem in the homework. It looks just like these. The nice thing about the homework is that at least they give you a nice coordinate plane to make your graphs on, so you're not sketching them. Okay? Thank you for watching, and have a great day.